So this exercise is related to the space physics questions. The planet Mercury orbits the sun. As you can see, the orbit of the Mercury, and the sun is there at the center. Mercury takes 88 days to orbit the sun. That's the time period. Average radius of the orbit is 58 million kilometers. Calculate the average orbital speed. So how to calculate the look, we have the formula speed is distance over time. But whenever object move in a circular path, the distance is a circumference of the path. So speed will be equals to 2 pi r divided by t. So it will be 2 pi is 3.14. And what about the radius? 58 million kilometers. So I can say it will be 58 million means 10 power 6. I'm not converting a unit like because give the unit as well. They give an option. So I can write my answer in kilometer per days. So that's why I'm not converting a unit. I'm just using a value divided. So this will be kilometer and the time it's 88. So what's the answer? 2 into 3.14 into 58 million divided by 88. 2 multiplied by 3.14. Tell an exponent like 4.14, 10 power 6. Okay. So 4.14 into 10 power 6 kilometers per day. Like 1 day, that will be the speed. Or I can have, because they did not specify a unit, so I can convert into kilometer and then the time in seconds and then, or convert kilometer into meter and time into second, and then it will be meter per second. SI unit is meter per second, but because the option is given, give the unit, so I can write my answer in any unit. So 4.1 exponent 6 will be there. Comets also orbit the sun. Name the force that causes the comets and the planets to orbit the sun. What we call this force? So that's a gravitational force. Add to a diagram opposite to show the orbit of a typical comet. Like this diagram, you can annotate on the screen and sketch the path of a comet. What should be the path of the comet? Elliptical. It should not be circular, elliptical. And the center of the path should not be the sun is one of end of the focus, not the center of the ellipse. Like if you draw like this in exam, these are fine. If you draw like this is wrong. Because even though it's elliptical, but not center of ellipse is not the sun. One end it is closer than the others. The speed of a comet changes during its orbit. On the orbit you have drawn, label with the letter X where the comet has a fastest speed. Example, I will draw the comet orbit and then you will label where it is fastest. So this is the orbit of the comet. Which position it is fastest? So near the sun, because it will have a smaller gravitational potential energy, so the total energy is conserved, so it should have the highest kinetic energy. So near the sun, the minimum position, at position where it is minimum displacement, that position it should have a maximum speed or the kinetic energy. Explain why the comet has a fastest travel fastest point X. So the point you have to mention the energy is conserved. One point is for mentioning the total energy is conserved. The second point, the total energy is equals to potential energy and kinetic energy. So near the sun, the potential energy is minimum. So it has maximum kinetic energy or speed. Because if the kinetic energy is greater, it will have the highest speed there. So it is important that you use this term. This will score 1 mark. The total energy is conserved, which is a sum of kinetic and potential. It's important whenever you relate the speed of a comet, you should always refer this point. And the second point, near the sun, the potential is minimum, so kinetic energy should be maximum. Yeah, that's right, because the energy, that was correct. So in 1969, astronaut left a reflector on the surface of the moon. The reflector consists of a mirror at an angle of 90 to each other. The scientists on the Earth aim the light from a laser at a reflector, and the light reflect back to them. This is how the diagram shows two mirrors in the reflector. Complete a diagram to show the path. So the scientists are sending the light from the Earth. That's how they send. Then it will reflect from the first mirror, and then it will reflect from the second mirror, and it will reach us. You don't have to draw an eye. This is the path of a light. So it will undergo a reflection. So striking the mirror, then reflection, then another reflection. The next is the speed of a light in a vacuum is 300,000 kilometers per second. The average time for a ray to travel to the moon and return back is 2.6. Show that the moon is about 400,000 kilometers from the Earth. Because it's an echo or a reflection, so whenever there's an echo or reflection, the speed is twice the distance over time. Because it's going and returning back. So if we need the distance, so it will be speed multiplied by time divided by 2. That will be the distance. So speed is 300,000 kilometers. The time it took 2.6 and divided by 2. So 300,000 multiplied by 2.6 divided by 2. What's the answer? So it will be like 300,000 times 1.3, which is 390,000. And the unit will be kilometer. 390,000, which is approximately 400, because this is about, so this is correct. The scientists measure the time for a light to travel to the moon and back very accurately, but the time is different every day. Like the sun time, the light reflected from the moon is coming in a short time, and some days it's everyday cycle is there. The graph shows how these times changes over a period. Like say on the 8th Feb, it came about 2.47 seconds. So different days, different time interval, different time it takes. What you suggest, what can be deduced about the orbit of the moon from the information of the graph? First, what is the orbit of what you can deduce, like some days the light from the moon is coming in a short time compared to other days. So it's not circle, that's right. So, and how you conclude, like 1 mark is, it's not a circular, because, and reason is that you will quote the values, you will say, like on the 8th, it took 2.47 second. That is also a good point. The Earth is not at the center of its orbit, or the orbit of the moon is not perfectly circular. It might be elliptical. So some days, like some position it is closer, some position it is further. And you will mention when moon is closer, it will take Lagrange of 3 mark, 1 mark. The orbit is not circular. 1 mark when it is taking a shorter time, moon is closer to the Earth, and when it is taking longer time, moon is further from the Earth or far. And about 20 days, 28 days is the orbital time for the moon that you can mention. But From this figure, it's hard to conclude that because we don't have a full cycle. If I was having a graph like this, then I can conclude the time, the during, like I can say that the orbital time is 28 days, according to, because we have to use this graph. So this was, scientists also discovered that the average time for a light to travel to moon and back increases gradually over every year. What further information does this give about the moon? Like every year, the distance, no, yeah, redshift is there, but what information this gives? There will be a redshift, but so it means the moon is moving away. That's right. There will be a redshift. The moon is moving away. So moon is moving away. There's a recession, or they can identify that by a redshift. They're not asking how they identify. They're saying what you can control. They will identify by the redshift, like light which they send and the light which they receive. So in this scale, universe is expanding. From the moon, it's hard to say that the universe is expanding because some objects, stellar objects, are moving closer, some are moving